Welcome students to Elements and Compounds Part 2. In this video we will talk about elements, types of elements, structure of atom and symbols of element. An element is a pure substance that is made up of only one kind of atoms and cannot be broken down into simpler substances. Example: carbon, sodium, silicon, aluminium, silver, gold, oxygen, chlorine, and many more. There are two major groups of elements, metals and non-metals. Like iron is a metal, oxygen is a non-metal. They are clear-cut metal and non-metal. Metals and non-metals are grouped separately on the periodic table. But there are some elements which have some properties of metals and some of non-metals. These elements are called metalloids. This is how the periodic table looks like. The elements of the periodic table can be divided into three main categories: metals, non-metals and metalloids. On the left side, blue part, that is your metals. Green part, they are non-metals, and the purplish, which shows properties of both metals and non-metals, in between, they are metalloids. Let's look at some specific properties of metals. Metals are good conductors of electricity, like copper, silver and gold. They are good electrical conductors. In a conductor, electric current can flow freely. Since metals have free electrons, they can carry a charge easily. Some examples of metals are nickel, rubidium, gold, copper. Metals have luster. That means they are shiny. Another quality, they are non-brittle. Non-brittle means malleable, that they do not break easily. In fact, they can be hammered into thin sheets. Gold is the most malleable metal. Some properties of non-metals, they do not have luster. That means they are not shiny. In fact, they are dull. Whereas we read that metals, they are shiny. Non-metals are brittle, so they break easily. This means non-metals are not ductile or malleable. Ductile means that they cannot be stretched into the wire, and malleable means not beaten into sheet. Non-metals are poor conductors of heat and electricity. Let's have a look at the general difference between metals and non-metals. Metals are shiny in appearance. They are usually solids except mercury, which is liquid at room temperature. Metals are malleable. They can be beaten into sheet. They are ductile. They can be stretched into a wire. They are sonorous, that is, they give deep and ringing sound. Metals, they have high melting and boiling points. Metals are good conductors of heat, and they are also good conductors of electricity. Whereas non-metals, they are dull in appearance. They are gaseous in state, liquids or solid at room temperature. They are brittle, that is, they break if they are solid. They have low melting and boiling points. They are poor conductors of heat. Also, they are poor conductors of electricity except carbon and graphite. Now, let's look at the properties of metalloids. Metalloids have properties of both metals and non-metals. Few examples of metalloids: germanium, silicon, polonium, arsenic. As we read metalloids, it shows both the properties of metals and non-metals. That means it can be hard, it can be soft, it can be brittle as well as it can be non-brittle. Brittle at both the qualities. It can be shiny as well as dull. So some of the metalloids, it may show both the properties or one of the property. Suppose germanium is shiny, but it can be hard. So they show both the qualities of metals and non-metals. The noble gases. The group 18 elements are called the noble gases. They are a part of non-metals. This is because they rarely combine with other elements and are found only as combined elements in nature. Their reactivity is very low. We know that elements are made up of similar kinds of atoms. But do you know the constituents of atoms? Let's look at the structure of atom. Atoms are made up of three different types of subatomic particles called proton, neutrons and electrons. Protons and neutrons are found in the nucleus. They are known as nucleons together. Nucleus is positively charged because the protons are positively charged and the neutrons are electrically neutral. Since neutron does not carry any charge and proton is positively charged, P for positive, P for protons, so we can say the nucleon, it carries a positive charge because neutron does not have any charge. So the nucleon carries positive charge. Nucleus is positively charged because the protons are positively charged and the neutrons are electrically neutral. Electrons rotate around the nucleus in a certain orbit called shells, just like planets rotate around the sun. Let's have a look how the subatomic particles of an element look like. Here in the first one, we have got helium, which has 2 protons and 2 neutrons in its nucleus. It has 2 electrons moving around in the nucleus. That is, the yellow part, they indicate the neutron and does not carry any charge. Whereas the red particles, they display protons, which carries P for positive, P for proton, and they both are called nucleons. And around the nucleons, we have an orbit or shell where the negatively charged electron, they rotate. In the next one, we have got lithium, which has 3 protons and 3 electrons. When we say 3 proton and 3 electron, then we will have 3 neutron also. Look at the structure. We have got 3 positive charged protons, and along with that we have got yellow color neutron. So the nucleon, it carries positively 3 charged protons, and around the nucleon we have the orbits, or we have got 2 shells, because the first shell, it always carry only 2 electron. So lithium, it has 3 electrons. So after the first shell, we have got another shell where the third electron, it rotates. So lithium has 3 protons and 3 electrons. 2 of the electrons are close to the nucleus and the third one is further away. These different locations for electrons are called energy levels or shells. The inner shell can only hold 2 electrons, then the outer shells hold up to 8. Now let's talk about how did the elements got their symbols. Before that, let's have a look at the picture. While traveling on the road, you must have come across various signs as shown alongside. What do these signs represent? These symbols represent traffic rules. A symbol is basically a short representation for anything, and each element is represented by a symbol. John Dalton, a British chemist, was the first scientist to use symbols to represent one atom of each element. The symbols used for some elements by Dalton are shown here. However, the symbols used by Dalton were inconvenient to use and also difficult to draw. J.J. Berzelius, a Swedish chemist, suggested a convenient method for representing an atom of an element. He proposed that the first letter or any 2 letters of the English or Latin names of the element should be used as its symbol. For example, the symbol of carbon is C, the first letter of English name. The symbol of calcium are C and A, first 2 letters. The symbol of hydrogen is H, first letter of English name. Now, the symbols of some elements begin with the same letter of their spellings. For such elements, the symbols given are either the first letter of their English names or first and second letters or first and another letter of their names. The first letter is always written in capital and the second letter is always in small letter. Let's have a look at few examples here. For the symbol of hydrogen, we have taken first English letter H. For beryllium, we have taken first 2, B and E. For arsenic, we have taken first and another letter of their name, that is A and S. In sulfur, we have taken just first letter. In calcium, we have taken first and second. Chlorine and calcium, they both start from the similar letter. So here in the chlorine, they have taken C, the first letter, and L, another one. In chromium, again it starts from the C. So they have taken C from the first letter and then R from another, and so on. The symbols of some elements are also based on their Latin names as shown here. The symbol for gold is AU. First 2 letters of the Latin name aurum. The symbol for silver is AG. First and third letter of the Latin name argentum. The symbol of potassium is K. First letter of Latin name kalium. Here we have got iron and mercury, again ferrum and hydrogerrum, the later names. Now we wind up with the first 20 elements of the periodic table. Please learn them.